Good afternoon, reInvent. How are we all doing? Yes, there we go. Cool. Welcome to Scaling Up to Your First 10 Million Users. My name is Brian Farnhill. I'm a solutions architect with Amazon Web Services. I'm based in Canberra, Australia. So, g'day, mate. I have Hong with me here today.
Yeah, my name is Hong Pham. I'm a strategic account solution architect, and I'm based in Seattle. Excellent.
So, let's get things started. One of the things I wanted to ask you guys to get a bit of a feel for who's in the room and where we're at. What are your goals around scaling? So can I get a show of hands? How many people have web applications or apps right now that have thousands of users? What about tens of thousands? A few more? Hundreds of thousands? Still going, you can see the trend here. Millions? Who's got tens of millions of users right now? Excellent. So take note of all the hands that are up and go and find them and have a chat afterwards. One of the great things about being in person at an event like this is the networking. And you don't get to 10 million users without having some interesting stories. So absolutely go and find those people. Now, in terms of scaling, luckily for me, scaling a web application is far less physically demanding than scaling up a hill or a mountain. But there we go, got a laugh. We need to figure out where we're going to start. And being technical people as we do, when we need to figure something out, we start with the search engine. So let's go to our favorite search engine. We punch in scaling on AWS. Now, what's turned up there is just some light bedtime reading, 66 million results. And every single one of them starts with AWS Autoscaling. Now, this is not actually where I want to start with you guys today. Because if autoscaling was the one-size-fits-all solution, I would say, thank you for coming, and we can all go have an hour back in our day. But if we sort of look at the broader set of options we have within AWS, there are so many different things we can do to help scale different parts of your application that there really is so many options to pick from that autoscaling is maybe not where we want to start. So if that's not where we're going to begin, where do we actually start? So there are a few points that I sort of like to lay out before we dive into the depths of scaling. And one of them is around understanding what the AWS Global Infrastructure looks like. So as of today, we are 22 geographic regions. Within those regions, there is a total of 69 availability zones. And as I found out an hour before we came on stage here, that 187 points of presence is now actually 199. We tend to keep changing things rapidly. And so what that equates to is a really great platform for you to spread out across the globe and leverage that to scale your applications. Now, if you haven't already seen this particular map, if you go to infrastructure.aws, it's an interactive map that you can sort of click your way around and drag and have a look at where all of our infrastructure is and how it's all connected from a networking perspective. So it's good background to have before we start making decisions about how we're going to start scaling. The second thing I like to start with as well is talking to the breadth of services. Now, the reason this is important from a scaling perspective comes back to the old adage that if all you have is a hammer, everything looks like a nail. But fortunately with AWS, we've got a lot of different types of hammers. So that means I can pick the appropriate services to be able to scale my application in ways that make sense to me. So having that breadth of over 170 services means that I can cherry pick out the right pieces for the right components of my architecture. Now, in terms of leveraging those services, if we take a sort of building blocks style approach to them, one of the things you'll see is that there's some key differences between how different groups of services operate, and I've called them out here. The services on the left of the slide in the blue there are ones that are highly scalable, highly available, and fault tolerant by default. So AWS build them and operate them to be like that for you so that you can just consume the service as you need it and don't have to spend time worrying about how to keep it highly available. We will do that for you. So in that category are things like CloudFront, Route 53, SNS and SQS, our Elastic File System, our load balancers. There's a whole lot more that we couldn't fit on this slide, but they're just some examples. Now, on the right are services that can be highly scalable and highly available with the right architecture. So what that means is if I'm looking at an application that runs on EC2, I need to make sure that I architect it to run across multiple availability zones so that I can have that resiliency built into my application. Now, this is not to say that one set of services is inherently right or wrong. You can pick the one that makes sense for the type of application you're doing, but you just need to be aware of some of those differences in terms of how you're going to architect. Now, when we want to set off on a journey of scaling, there are things we want to consider up front. And discussions I have with my customers will typically go along the lines of, we need to come up with the world's most magnificent architecture before we start cracking out a line of code. And that's not necessarily the approach we want to take. I like to refer to this quote from Jeff Bezos: many decisions are reversible two-way doors. So what this means is that if I make a decision to architect a particular way, more often than not, I'm not necessarily going to be locking myself into that particular architecture. I can try something, experiment. If it works, great. If it fails, I can fail fast and then move into a different service or a different way of architecting and learn from everything that I'm doing as I operate my app. So keep that two-way door decision in your head when you start planning out your architectures, because the more data I've got from running an app, the more data I can use in how I architect it to be better and scale more. So taking that approach, we come up with a bit of a flywheel that looks something like this. We begin by building our application. And once I've built it, we start operating it for a little while. I want to be able to take measurements. How long is it taking particular components to load? How is my database performing? What's the response time to my end users? You need to be able to measure your app to be able to identify where any bottlenecks are. Once you've identified bottlenecks and you start to learn from that telemetry, we can figure out, okay, well, I can see that I've got a particularly poorly performing database query. What do I want to do about that? Do I want to fix the query? Do I want to change the database size? Do I want to add some caching? There's lots of different options, but that takes me back into the build phase. So I make my improvements, and then we go and repeat the cycle. We measure, we learn, we build again. There are also some other guiding tenets that I'd like to call out as being across this entire slide deck. The first one is around identifying and avoiding undifferentiated heavy lifting. So these are the things that you need to do to keep the lights on, but don't necessarily add a lot of value to your application. So things like patching database servers and keeping them highly available, for example. I could leverage Amazon RDS for that and save myself some time. The other term that goes along with the undifferentiated heavy lifting is the term yak shaving. And for anyone who hasn't heard yak shaving before, in its simplest definition, it's adding complexity to an otherwise simple task. So, for example, and developers hit this quite often, and I put myself in this category. I've been guilty of this multiple times in my career, where you set off with a goal in mind. Like, I need to fix the performance of this particular page. So I get in, I start coding, and I'm like, hey, there's a problem over here. Let me get that one too. And there's another one, and you sort of start diving deeper and deeper and deeper until one day you're just hanging out and bzzz. Hey Brian, what you doing? Bzzz. I'm shaving this yak. Bzzz. Why? It's a really good question. Yeah, okay. So being able to recognize when you're down the loophole and you're yak shaving and say, you know what, maybe I need to reevaluate how I'm trying to solve this particular problem. That's something we like to keep in mind. The second one is around serverless versus things that you manage yourself. So back to the previous slide there where we had the blue and the red services, keeping in mind what selecting either of those means in terms of operations and how I maintain and how I scale is something you want to have in the back of your head. And one other call out that we've got here as well is security first. Now, security is our top priority at AWS, and we want that to be your top priority for your customers as well. So making sure as you scale, you implement the right security services to be able to go and do the things that you need to do. So you've probably heard the phrase, it's always day one at Amazon. What better place to start on our scaling journey than day one? So let's say I've got an app and I've got more than one user using my app. I might have an architecture that looks a little bit like this. I've got Route 53 providing DNS. I've got an elastic IP address sitting in front of an EC2 instance. I'm running a web application there for argument's sake. And I've got a separate database sitting on another instance. So fairly straightforward application architecture. Now, for those who are looking to get started with something similar or something a little bit smaller and who don't know a lot about AWS and getting started, Amazon Lightsail is actually a really great service to call out here because it can help you get started in minutes. And it can bundle up your compute, your storage, your networking, and give you a really simple process to get some common application patterns deployed quickly so that you can start operating and see how they behave. Once you decide you've outgrown Lightsail, then you can take those resources and start managing them yourself and move forward with the rest of the AWS stack. So it's a great place to start. But where I want to focus first is around the database options. So in my previous architecture diagram there, I had an EC2 instance that was running my database server. So this is what we call self-managed. So here I can deploy whatever database engine I want, I can configure it however I want, and I can do anything I need to with it. Very, very flexible. However, we've also got a range of fully managed database options. Now, what these are mechanisms that you can deploy that will give you database functionality in a range of different forms, where AWS will do things like making it highly available if you tell us to do so, or things like providing different types of storage to suit different database needs. So you might have heard of the term of polyglot persistence, essentially being able to pick the right data store for the right type of storage. We've got a range of services that you can implement as you need for different types of storage and move your application architecture forward from there. So a couple of them on this slide, so RDS for relational databases, DynamoDB for NoSQL, Neptune for GraphQL. There's a bunch of others like QLDB as well. One in particular I want to focus on here is Amazon Aurora. So what Aurora is, for anyone who's not familiar with it, is an database application that we had created that was designed to provide enterprise functionality at open source pricing. So we've got a MySQL and Postgres compatible versions, so you can pick the one that suits your particular application stack. And it does things like creating up to 15 read replicas if you want them. We do 6-way replication across 3 availability zones, and we can do continuous incremental backups to Amazon S3. There's also a serverless option, which I find quite cool. Now, what does a serverless database engine look like? There's essentially what we do is we break up the compute and memory usage from the storage so that we can scale that compute layer independently. So as your database starts getting more connections and starts doing more work with queries, we can pull in additional nodes from a warm capacity pool and make them available to your cluster as you need them. And then when you no longer need them, we can remove them. And you only pay by the second for each of those compute nodes that you pull in. So that gives me a really effective auto-scaling mechanism for my database tier without me necessarily having to go in and configure specific components. Now, one of the other questions that we get a fair bit around starting out and looking at data storage is to NoSQL or not to NoSQL? That is the question. And my advice here, as controversial as some people may find it, is start with SQL databases. Hear me out. There are a lot of really good reasons to start with SQL. Firstly, it is a very well-known technology. It's very well established, lots of books, tools, expertise in the marketplace, very clear patterns to how you scale a SQL database. And the reality is that you're not going to break a SQL database in your first millions of users. Like, you're really, really not. Unless you're doing something super peculiar. So if you've got massive amounts of data, then you might want to be looking at NoSQL, but chances are you'll probably still have a SQL database somewhere in your stack and other elements of in NoSQL. Now, some of you in the audience might be here thinking, hey, hold up, Brian, hold up. You said unless you've got massive amounts of data. Aha, we've got massive data. Let me quantify that for you a little more. If you're generating more than 5 terabytes of data in your first year, and you've got an incredibly data-sensitive workload, then okay, you might need NoSQL. There are some other use cases that you might want to look at there as well. Things where you need super low latency, scenarios where you need to be recording thousands of records per second, where you've got highly non-relational data, or where you need a schemaless construct. And I'd like to emphasize, need a schemaless construct. It does not equal my developer thinks it's easier to write code in a schemaless construct. Other things that you'll want to start looking at as you scale up past your first 1 or 2 users is how you identify those users and looking at the sign-in experience. Now let me ask you this question. When was the last time any of you signed up for a new app or service and you decided to go and tell one of your friends about it, and the conversation went like this? Hey dude, you've got to check out this new app I've just signed up for. The sign up form was fantastic. It's the most amazing experience ever, and it is the coolest thing. What does the app do? I don't know, but look at the sign-in experience. We don't talk about this because it's just expected that apps these days have the ability to sign in and reset passwords and do multi-factor authentication. It's just having a good app these days. People don't get blown away by that. So if I'm trying to prioritize where I want to apply my effort and work, it's to things that make my application more valuable and to stand out, not necessarily to just keeping the lights on and having a sign-in form. So that's where Amazon Cognito comes in. Cognito provides a managed user directory, and that's my users sign up and reset passwords and do all of that sort of stuff. It gives you a hosted UI that you can use, or you can create a custom UI if you need. And you can federate out to a bunch of different sources like Google, Facebook, Amazon, or any OpenID Connect or SAML provider, which makes it very, very easy to provide a broad range of sign-in experiences to your users without you necessarily having to code up each one individually. You can then take those credentials and exchange them for AWS credentials, and you're off and running against your application. So again, this is another one of these services that scales for you. I don't need to worry about the load that gets generated by that hosted UI, because that's put somewhere else for me away from my application, and I can just get the tokens back. So Cognito makes a really great way to get going quickly with the basics of user authentication without me needing to worry about how it's going to scale beyond my millions of users. All right, so let's say my application's slowly starting to get a little bit more successful and we start creeping past the 100 users mark. Now, I might make a couple of basic changes to my architecture here. I've put an RDS instance in instead of that managed database instance I had, and I might be using Cognito there on the application layer. So life is good, and now I've got a little bit of time on my hands to start looking at what comes next. So let's say, take it up to 1,000 users. What does this look like? Now, before we dive into the specifics of this, there's a couple of scaling concepts that I want to call out just to really quantify them. And that when we talk about scaling, there are essentially two types. There is horizontal scaling, and then we have our vertical scaling. Horizontal scaling is adding more nodes to account for load. Vertical scaling is taking the nodes that I have and increasing their size. Now, there are scenarios where either of them could be the right option for you. If you take the approach of we're going to need a bigger box, this is actually the simplest approach to scaling. I can just take my instances, make them bigger, and I can generally handle more load. Now, this is also good in that I can be very particular about the type of EC2 instances that I would like to use. We've got CPU-specific instances, memory, network, storage. You can really pick the right size and instance type to fit your application. The problem with vertical scaling, though, is that you will eventually hit an endpoint. If I keep doubling the size of my instance, I'm probably going to start seeing diminishing returns at some point where double the instance size does not equal double the ability to process throughput. You also need to think about things like what happens when you architect for failure. If I've only got two very large instances and one of them fails, I've just lost 50% of my ability to process load. Whereas if I have 10 different nodes that are smaller and one of them fails, I've only lost 10%. Which means I can still handle 90% of the traffic that I would have been doing otherwise. Now that said, there are plenty of valid reasons to do vertical scaling. One that I see in a lot of my customers is usually licensing. Right? We've only got licenses for X number of servers, so horizontal scaling is not an option. So again, pick the fit that's right for your application. So let's add a little bit of horizontal scaling to our architecture. I've added a secondary instance on my RDS, and that gets handled for me. So I don't need to worry about how that fails over or how that works, which is great news for me. I've added an extra web instance, and so now I've come up with the concept of, okay, how do I load balance across those? If I was in an on-premises world, what I would need to do would be put a load balancer in, configure it, and then make sure that it can scale and be highly available, and have to spend some time managing that. So that's more overhead for me. What we've got in AWS, though, is we have a range of different managed load balancer services that you can pick based on your application's needs. Now, on the edge there, we have the classic load balancer. So this is our legacy load balancer that's been around for quite some time. The other two, the application load balancer and the network load balancer, These are our current generation load balancers. So the NLB is a layer 3 device. The application load balancer is a layer 7. And typically speaking, we talk to customers about starting with the ALB until you can find a reason that you don't fit the needs, don't fit the use case of the ALB. So things you get out of it, it's highly available and managed for you. You just configure what it needs to do in terms of forwarding requests, and you're off and running. We can do content-based routing, so route based on paths or headers or other parameters to send things to different locations, which is great. We have things for session affinity, health checks, HTTP2 and WebSockets. So there's a bunch of great functionality you get out of that ALB, and you don't need to worry about how it scales and how it stays available. AWS will manage that for you. So let's keep going. Let's go past 10,000 users. So I'm scaling horizontally here. I've added a lot of instances. And you might notice here that what you're seeing is the database tier is still only 2 servers. So one of the things we can do to scale RDS horizontally is to leverage the concept of read replicas. So what I'm doing here is that any connections that are read-only, so just displaying data back to my users as opposed to committing new content to the database, I can leverage a connection there that will go to one of the read replicas as opposed to my primary. Now, what this means from a scaling perspective is my primary database server is now handling less requests, which means it can handle more write requests, and I start scaling like that. So if you think back to Aurora that I mentioned earlier, it can have up to 15 read replicas, which gives me a really great horizontal scaling mechanism for my database tier. Once we hit this point in the game, though, this is where I want to start looking at how do I start shifting some load around? Right? How do I take load off my web servers and put it somewhere else? One of the really easy models that I talk to a lot of my customers about is being able to leverage Amazon CloudFront and Amazon S3 for static content. So Amazon S3, if you haven't heard of it, it's one of our oldest services, is an object-based store. So you can store files and content in there, and it's infinitely scalable. Objects can be up to 5 terabytes in size. We have options for encryption at rest and encryption at transit. And it's really great for static website assets. So if you think about like your JavaScript files, your CSS, your images, things that don't require a database lookup of some sort to be able to return, I can store all of those in an S3 bucket and then make those available via CloudFront to my users. So CloudFront is our content delivery network, up to 199 points of presence. And essentially, this can help us lower the amount of load that hits my origin, so my web servers in this particular case. Now, we can do streaming video, we can do custom SSL certificates using Certificate Manager, and the really cool thing here is we can actually use CloudFront for dynamic content as well as static. I can create a TTL, a time to live, as low as 0 seconds, which says I don't want to cache content in CloudFront, but I do want to use CloudFront's global network to accelerate how my users can come in and get to my application to get to that dynamic content, creating an overall better user experience. So when we start looking at the orders of magnitude of improvement we see, when we start with no CDN and we go to having a CDN for static content versus then adding the CDN for dynamic content, we can really start fine-tuning how that's going to behave. It also might make sense to look at how we cache dynamic content in CloudFront. For example, if I've got search results and I can store those based on a query string, I can tell CloudFront to cache those independent pages based on the query string alone. So that way I can still cache elements of my site without necessarily having to worry about the fact that some of those calls need to be dynamic. So we've started shifting some load around. Let's shift a little bit more load around. So what I've added in now is some cache nodes hanging off those web instances. So this is for being able to cache database responses. If we take a typical SQL query, it might take in the order of magnitude of hundreds of milliseconds to maybe seconds to run if it's a big query. And I don't necessarily want to have to take that time on every single page request. The quicker I can get it back out, the quicker my users get it. And if I can take some of the load off RDS at the same time, that means my database server can handle more requests of other things. So this is where Elasticache comes in. So Elasticache is a managed Memcached or Redis cluster. You pick the particular engine that you'd like to work with, and you can start a single node and you can scale up to multiple nodes across multiple availability zones to have a highly available, managed in-memory cluster. Now what this means is I can store the results of a database query and it'll be stored in memory in that cluster so that it will be returned typically in single-digit milliseconds, which means my web server gets its data much quicker, can get my content to my users quicker, and I'm having to hit the database less, which frees it up from a compute perspective to handle other things. So let's shift even more load around. Right? We're just ripping requests out of this web server left, right, and center. What I'm adding now is DynamoDB. So as I mentioned earlier, you're going to want to look at NoSQL at some point in your scaling journey. But SQL is still a part of what I've got here, so I'm not ditching RDS altogether. What I'm doing is I'm looking at how my data looks and what makes sense to put into Dynamo and what makes sense to leave in RDS. So where I have schemaless data or non-relational data or things that are like metadata, they're a really good story to put those into DynamoDB. And then I can scale that independently while freeing up RDS to do more things. So DynamoDB is our managed NoSQL option. You can pay for provisioned throughput, or you can have it in on-demand mode if you're unsure about your load. We've got an auto-scaling option in there on Dynamo as well, so we can scale up and down in terms of your read and write units. Dynamo is built to give you fast, predictable performance, even at very large scales. Like I said, thousands of records per second is bread and butter for Dynamo. We can store JSON objects and filter based off JSON attributes. There's streams and triggers for being able to integrate with other AWS services around you, which makes it a really great place to store data and then be able to connect off to other AWS sources to do background processing or analytics or any of those sorts of things. So now that we've been through all of that, our web tier is a lot lighter. And now that it's a lot lighter, this is the point where I'd like to take you back to the start of the presentation and our old friend Autoscaling. And for that, I'm going to hand over to Hong to take you through the rest.
Thank you, Brian. So as you have done a lot of work to evolve your architecture, this is probably the right time to talk about how to optimize your compute resource. And to do that, we're going to look at autoscaling. So this is a typical weekly traffic to Amazon.com website. During the day, you can see the traffic increasing, and it dropped out at nighttime. So when we provision capacity, we want to provision at peak. That means we want to create ahead of time capacity that can support the busiest time of the day. But not every week is the same, and not every day is the same. If you look at the last week of November, the last 2 days on Thanksgiving and Cyber Monday is super busy, traffic shoot up dramatically. So if you follow a traditional way of provision capacity, that means you have to add capacity that can support the most busiest day of the month. But if you think about it, only 24% of your capacity actually in use. And the rest, 76%, will be there sitting idle and not delivering value for your business. And that's not what you want to do. What you want to do is ability to spin up resource or to delete resource based on the traffic coming into your web application and based on business demand. So if you look at this graph, you can see that the blue line is the compute capacity and the yellow line is the traffic coming in. And you want those lines goes along together. So capacity will increase when your business is busy, and it goes down if your business slow down at nighttime. And autoscaling will let you do this. So with autoscaling, you can automatically decide the number of nodes in your autoscaling cluster. You can choose what is the minimum number of nodes, what is the maximum number of nodes. And you can use metrics that are provided by Amazon CloudWatch to define when the scaling activity will happen. Adding to that, autoscaling can check an EC2 instance if it's healthy or not, and it will replace EC2 instance if it's not healthy. So when you mark 500,000 users, your architecture probably should look like this. You have EC2 instance belong to a cluster of autoscaling group, and it spans across multiple availability zones because you want to make sure you have high availability. So your infrastructure growing, that's exciting. But we need to think about if we can use automation to replace day-to-day manual tasks, because you want to limit amount of human activity in your AWS account. So AWS System Manager can let you automate day-to-day operational tasks. So you can use System Managers with EC2 instance in AWS Cloud, or use it for your server in your on-premise environment. System Manager can manage remote access to your EC2 instance so that you don't have to have a bastion host, which means you limit the number of human errors in your AWS account. And like I said, System Managers can automatically run your day-to-day tasks. For example, if you want to patch your Windows EC2 instance, or you want to schedule a cron job for your Linux EC2 instance. Or when your developer or your team go out of the office on Friday night, you can use System Manager to shut down your dev and test environment and spin it up on Monday when everyone comes back to the office. Another cool feature of System Manager is compliant configuration. So this feature will scan the fleet of your EC2 instance and report to you if there's a drift in compliant configuration. Now, when you want to store secret, let's say database password or API key, using System Manager Parameter Store will help you secure those secrets. And all of these offered with reasonable price. So how about infrastructure automation? Well, AWS offers a wide range of options for you to automate your infrastructure. You can get started by using AWS CLI or SDK to interact with the endpoint of AWS services. And this way, you have controllable method to define the automation. Or on the other hand, you can choose to use managed service offered by AWS to manage your environment. If you use a chef cookbook or recipe, then you can use OpsWorks to create a stack, and that stack will have multiple layers, including your load balancer, your EC2 instance, or your Autoscaling group. If you're not using Chef, there's another service for you to have a managed environment, and this service is Elastic Beanstalk. So Elastic Beanstalk can create an environment for you with load balancer, EC2, Autoscaling, and all you need to do is upload your application code. So we talk about removing the undifferentiated work right here. So you don't need to manage or run your infrastructure because you can have these servers manage the infrastructure for you. So for developers who love container, there's so many ways for you to run and orchestrate your container application on AWS. You can get started quickly with Amazon ECS. And Amazon ECS can create container placed on the EC2 cluster that you define. For developers already love Kubernetes, you can use Amazon Elastic Kubernetes Service. It will manage the control plane for you. And very recently, EKS announced that it will manage the worker node for you as well. So here you go, it's a win-win situation. So for people who really love serverless, you don't want to manage your EC2 instance, and you love container, think about how you can use Fargate to help you in day-to-day managing your container application. So Fargate will let you place the container and manage the container for you, and you don't have to manage the infrastructure. As you use more and more service, automation is the key. And using infrastructure as code, you can define how your environment will look like by a piece of code. And the benefit of that is that you can scale, you can manage, you can provision environment quickly, and you can share the piece of code with other teams as well. On AWS, to do that, you can use CloudFormation to create CloudFormation template. And CloudFormation template will interact with other services to create a resource for you. Another tool is AWS Cloud Development Kit, or CDK. So with CDK, you can interact with AWS and create resource just by writing a few lines of JavaScript. And that actually reduces the amount of time you have to develop or you have to manage your environment. How about deploying? How about code release process? So in AWS, you can build an automatic pipeline to release your code using code pipeline. So you can get started with having a developer workstation on Cloud9. Your developer can log in and start writing code, check the code to code commit within a private repo. And when the code and code commit, it can trigger a build that runs and managed by code build. After it's done multiple types of tests that you can define, then you can choose to have code deploy to deploy the new version or new artifact to the cluster of your EC2 instance. You can create this pipeline manually, or you can use CloudFormation, or you can get started quickly by using CodeStar. So with CodeStar, when you create a project, those managed servers will be created for you, and you can share the projects with other team or other member of your team and quickly develop. Now, automation needs to go hand in hand with having visibility. That means you need to have a strategy for monitoring and logging. So when you implement monitoring and logging, think about what is the purpose, right? Is it for security audit? Is it for gaining visibility, for resource utilization? Or you just want to know what is the customer experience from your website or your application? There's multiple ways to get metrics and logs. The first one, of course, you want to look at is the host level metric, right? Such as CPU utilization, such as network in and out. However, to gain more insight, you can start using aggregate level metric. Instead of looking just one EC2 utilization for one instance, you can combine the utilization metric of many EC2 instances. And you can use statistical threshold to have insight what is the common and uncommon behavior. For example, when you say P90 of your EC2 instance CPU utilization is 70%, that means 90% of your EC2 instance have utilization 70% most of the time, or less than 70%. And the rest 10% are the bad one. That means it have CPU utilization more than 70%. So using statistical threshold, you understand these are the normal behavior and these are the behavior that I need to act on. And adding to that, you want to understand what is customer experience. To do that, you can implement metrics for your website, your application related to customer experience. Let's say you look at the latency, how long it takes for the customer to load the website, or how many 404 errors that in the average the customer will have when they hit your site. And besides metric, you also need to collect log and analyze log. Have a strategy for central login location, right? You stream log from CloudTrail, or you stream log from GuardDuty to collect and analyze the log. Also, using Amazon CloudWatch log, you have ability to collect logs and analyze the log and act on it as well. So CloudWatch is a service that provides monitoring and logging. With CloudWatch, you have multiple ability to alarm or to raise notification for your team. One of the features that Amazon CloudWatch allow is Amazon CloudWatch anomaly detection. So it uses machine learning to look at a specific metric and see if there's any abnormal behavior in that metric. And if that is the case, it will generate a CloudWatch alarm and it will send you notification. So another feature of CloudWatch is CloudWatch Log Insight. This feature lets you use SQL statement to analyze your log, and it can visualize the results so that you can understand the data. So we have gone this far. We implement automation. We implement monitoring and logging. What else can we do, right? You may be asking. So let's look at how we can optimize your application layer. So far, we have talked about monolithic architecture. That means every feature and functionality is combined in one application. That means you have the front end, the business logic, and the data access combined in one application. So how can we improve this? To do that, let's look at SOA. And let's do a little bit of research on what is SOA, right? So if you do some research, you can see that there's so many results related to SOA. This is not what we want to start. And this is where we want to start. So service-oriented architecture, that's what we want to talk about. So service-oriented architecture means that you break down your monolithic architecture into multiple tiers, and you treat them separately. So in this case, you have the presentation tier, you have the business tier that have multiple services working together, and you have the data access tier. And these are totally separate. So why are we doing that? We breaking them down because we want to treat each tier separately, individually, so that we can scale them. And using this architecture, you have the flexibility and the scalability for your whole environment. So let's look at one example. You have an application load balancer in front of your cluster of EC2 instance, and your application running on EC2 instance just fine. So if you want to implement a service-oriented architecture, you can break down the functionality of your application and move some of them, containerize some of them into a container environment managed by Fargate or ECS. And then you figure out some of the features are very lightweight, and you can move them into Lambda. So AWS Lambda is a service managed by AWS for function as code. You only write a piece of code, you upload it into Lambda, and it will run the code for you. You don't have to manage the environment. And if you look at this diagram, all of these three services, EC2, Fargate, and Lambda, can be invoked by application load balancer. So you have one application load balancer, and you can route the traffic depending on what the request is. So the traffic can be going to Lambda, can go into Fargate or EC2. So when you're building more and more service, you're scaling horizontally for your service. Don't start from scratch. Don't reinvent the wheel. Look at what managed service already offer on AWS and think that you can use them to get started quickly. Right? On the screen, these are the managed service that we offer with serverless technology. And as you know, this is just a limit number of services that we put on the screen. So what we recommend is to get started quickly using managed service and trying the serverless technology. Now, when you're using serverless, there's one concept that we think that it would be worth it to visit. Loose coupling. Loose coupling means that in a system, one item shouldn't have any other knowledge, shouldn't know anything about other items in that system. So in your case, you have multiple services, or you call it microservice. One service shouldn't have knowledge on other services. So you may be wondering, how does service talk together, right? So that's when you implement queuing or notification into your system. You can use queuing by implementing Amazon SQS to manage the queue for you. Or you can use Amazon Symbol Notification Service to push out notification for you. And using queuing and notification, that's how you have multiple microservices talk together and communicate together. And these services, SQS and SNS, managed by AWS. And it's highly reliable and it's scalable. So implementing queuing and notification opened the door for event-driven architecture. What does that mean? That means that when you have a message coming into your queue, or when you have a notification sent out, you can use that event to invoke a compute resource. And when you're using serverless technologies, that means you can use a message or notification to invoke a Lambda function that will do some business logic for you. And that message or notification doesn't have to be SQS or SNS, right? It can be from DynamoDB Stream, it can be from Kinesis Stream, which is a managed service for streaming. And it can also from CloudWatch event as well. So loose coupling set you free when you implement microservices and you implement queuing and notification, this is how you can add more service, or you can update a service without impacting the rest of your system. And the looser that you set up, the easier for you to scale. So let's look at one example. In this example, we have a static website that hosted on S3. And that static website will be fronted by Amazon CloudFront, a CDN service managed by AWS. So on the authentication piece and user management, you have Amazon Cognito that will manage the authentication and authorization for you. On the back end, you have API gateway and Lambda that can write data to DynamoDB. So you may be wondering, how do I let my front end, which is a static website, talk to API gateway? You can use multiple JavaScript frameworks such as AngularJS or React or Amplify to call API gateway. Now, at this stage, your architecture probably looks like this. You have multiple services working separately, talking together. And the best part about that, you don't have to worry what is running in each services. For one service, you can run container fronted by ALB. On the other service, you can have API gateway and Lambda, and they can just work fine. If you want to re-architect one of the services, it should not impact other services in your system. So how do we troubleshoot if one of the services is having a problem? To do that, you can implement X-ray, which is a distributed tracing system. You implement X-ray to see where is the bottleneck, where is the error, what is the problem. So you can see that in the screen, there's multiple green circles. The green circle, each of them is one service, and the green one is the healthy. So if you see the circle have yellow or red color, that means there's some error or there's some issue over there. If you click at one of that circle, you can see what is the latency or what is the error. Now, when you mark 1 million users for your application, that's awesome. You make it here. Supporting 1 million users is nothing very different from what we have been discussed, right? What we have been talking about is implement multi-AZ architecture, enable load balancing using autoscaling, and implement service-oriented architecture. And your architecture diagram probably going to look something like this. If you look at the right side, you can see that we move some of the features, functionality into serverless with API gateway and Lambda. And then we break down our web tier into a worker node autoscaling group, or a web application autoscaling group, or an application level autoscaling group. And these microservices talk together using SQS, which is a queue that can take the message and deliver the message. So the next big step would be 5 million to 10 million users. And if you already implement SOA, if you already implement autoscaling, it shouldn't be a problem on scaling your infrastructure. However, you may run into a database issue, right? So when you need to scale your database, there are a few options to do that. The very first option is to do federation. That means you split your one database into multiple database clusters based on the functionality. So let's say you're going to use one single database cluster for the user, another database cluster for product, for example. So this method is convenient to start. However, you can run into the problem that one of the database clusters are out of hardware, right? So it's getting big and big that to the point you need to scale that database cluster in different way. So the second way to scale your database cluster is to do sharding. That means You have to implement a lot of logic in your application level to decide how to write or how to read from multiple database clusters that have the same schema. And with this option, it requires a lot of work from your application layer, but then you can scale horizontally. You can add as many clusters as you like. It does require some sophistication in the operation aspect. And the last option is to move some of the features to different type of database. So this option kind of like federation somehow. You figure out if one table doesn't need to be SQL, and you can move that table into DynamoDB, which is NoSQL. With this option, you have the flexibility of choosing the feature and functionality that can be scaled in different kind of technologies, such as NoSQL or GraphQL. So for now, we have gone through a lot of suggestions. I think we will hand over to Brian for recap on what we have been talking about.
Thanks, Hong. So let's take the last 50 minutes and compress it down into 3. To wrap up, some of the take-home points that we'd really like you guys to stick in your heads as you walk away from this session. Leverage multiple availability zones. Use services that go multi-AZ natively, or use EC2 and make sure that you configure it to leverage that. Make use of those self-scaling services, so the ones where you don't need to specifically configure them to scale, like the application load balancer, or S3, or the ones where you can control the scaling throttles, like SNS and SQS with the number of items you can put into queues. Build in redundancy at every layer. All right? It's IT, things break. You want to account for that. So as you break your architecture apart, make sure that you're doing it in such a way that you can account for individual component failure. Start with SQL. Just cannot stress that point enough. Like I said, you're not going to break it in those first millions of users, and it's going to be the easiest mechanism to get you going, and you can start taking content out and putting it into Dynamo as you see fit as you grow. Cache data both inside your infrastructure, leveraging something like Elasticache, as well as outside your infrastructure, leveraging CloudFront. You want to use automation. Automate all the things all the time. All right, the more automation you've got in place, the less hands-on effort you need to apply to making sure that your application runs smoothly and that your users have a really great experience. Make sure that you've got really good metrics, good monitoring, and good logging, because you can't troubleshoot a problem that you can't identify. Right, so having that data is critical to figuring out where you need to make improvements in your application architecture. Use that service-oriented architecture approach and break things up so that you can operate them independently, scale them independently, and monitor them independently. Use autoscaling when you're ready for it. Like we said at the start, this is not a one-size-fits-all mechanism, but it does play a key part as you scale your application. Don't reinvent the wheel. We said the event name. There's lots of services across AWS. Use the ones that you do exactly what you need, so you don't need to rebuild them and manage it yourself. And lastly, move to NoSQL if and when it makes sense to do so. So that gets us to our 10 million users. And before we wrap up, I just want to leave you with a couple of thoughts around, well, what if you need to go bigger than 10 million users and to infinity? Some things you're going to want to start considering at that point, just to leave you with this. Fine-tuning and monitoring are critical at this point. You're going to be very, very deep in the weeds about looking at the specifics of every component in your stack. At this point, if you haven't already, you'll be going from a multi-AZ architecture to multi-region. Really leverage that global footprint we've got and spread out across the globe to be able to get your users the experience they need. You might be looking at building your own custom solutions around things like deployment, monitoring, and operations at this point that will be very particular to your workload. So don't rule that sort of thing out, but try to use native components where you can to start with. And build serverless wherever you can. So next steps, things to go and do after you've spent your time here. A lot of reading is the short version. So our documentation and architecture sites have really great links and content to be able to get you started. The well-architected framework in particular, if you haven't heard of it, go and have a read. We cover 5 different pillars and lots of really good recommendations around cloud-based architectures. Our solutions and quick starts have code samples that you can reverse engineer and learn from, or even incorporate into your own solutions. And of course, all of them can be deployed into your AWS accounts, which can come with the free tier to give you services at no cost as you go through your first 12 months and then beyond. As you start doing things and you start having questions, this is where you want to look for help. Our forums is a great place to start, and AWS Answers is a really good site with lots of different content there as well. If you've got premium support, raise support tickets, ask us questions. We love it when customers do that. And last, but certainly not least, come and have a conversation with an AWS solutions architect, such as Hong and myself. This is literally our job. It's what we do, and we love helping customers optimize their architectures in AWS. So as you get to a point where you want to start validating your own knowledge and growing further, have a look at the AWS training and certification track. So there's a couple of architect-specific exams in there that you can use to validate your own learning, as well as online content and classroom materials to help you study for it. So this is all available in the architect path in the training website at the link below there. But otherwise, thank you guys so much for spending the last hour with us. I hope it's been useful. It's only Monday of reInvent, so remember, pace yourselves, it's a big week. If anyone has any questions or you'd like to have a chat, Hong and I will be hanging out at the back of the room. But otherwise, we're really grateful you guys turned up. We hope you enjoyed the session. Have a great reInvent, and please fill out the feedback surveys at the end. Thank you so much.